Okay, welcome to this video on proofs involving parallel and perpendicular lines. Before we actually write some practice proofs, we're going to first discuss the rules that are used in the proofs, and then we'll do a few practice proofs together. So, same side interior angles postulate. This is one of the rules that is used often to show some things about angles when we're talking about parallel lines and transversals. It says if two parallel lines are cut by a transversal, so I'm going to mark these parallel, and then of course we have our transversal, so we have A and B. Well, we're not going to name them these, we'll wait till later. All right, then we can conclude that for those parallel lines cut by a transversal, the same side interior angles are supplementary. So like if I call this angle X, I could call this 180 minus X. So we're using that to show that the angles are supplementary. There is an abbreviation for this you can use. Parallel lines imply same side interior angle supplementary, or you can call it the same side interior angle theorem. Okay, then we have the converse of this theorem. So with it, we're going to flip around what we know first and what we know second. So it says, if two lines are cut by a transversal such that same side interior angles are supplementary, so I have two lines cut by a transversal, and we have the fact that same side interior angles are supplementary, then we can conclude that those two lines have to be parallel. Okay, so we got that one. Here's the name of it. And here's the name of the first one. So we would write this with abbreviating converse of the same side interior angle postulate. These are both postulates. Notice they are assumptions that we do not prove. And then there's another little abbreviation that you can use too. So you have three ways you can write it. So for the rest of the theorems that we're going to do, they run like these, where there's a regular one and then a converse one. The regular one is whenever you're concluding something about the angles and you know the lines are parallel to start with. All of the converse ones are where you know something about the angles, but you're concluding the lines are parallel. And these two postulates are used to prove all the theorems for corresponding alternate interior and alternate exterior angles. Okay, so the first theorem. If two parallel lines are cut by a transversal, parallel lines cut by a transversal, then we can conclude that corresponding angles are congruent, like these two. I'm not going to mark them all. I'm just going to mark one set. So corresponding angles theorem is how you could abbreviate that. All right. And then there's a converse one where we start with the corresponding angles being congruent, which allows us to conclude that the lines are parallel. All right. So if we went back on this first page and wrote some of them down with symbols, let's do that. I'll do that in a different color just to make sure we understand. So let's say we have A parallel to B. That implies that, let's say, angle 1 and angle 2, angle 1 supplements angle 2. Okay, or the ones on the right if you prefer to call them that. But in the other one, in the converse, if we start with angle 1 supplementary to angle 2, then we can conclude that line A is parallel to line B. So for corresponding angles, if we start with line A parallel to line B, we conclude that angle 1, corresponding angles, is congruent to angle 2. The reverse is true here. If I start with angle 1 congruent to angle 2, then we can conclude that lines A and B are parallel. All right, let's do this. Usually at this point, I let the students break off and do the pictures for the other remaining ones, alternate interior with its converse and alternate exterior with its converse. So I would invite you to stop the video now and fill those in and then come back and check it. All right, alternate interior angles theorem. Alternate interior angle theorem, which says parallel lines imply alternate interior angles are congruent. If two parallel lines are cut by a transversal, parallel lines, then alternate interior angles are congruent. So let's say we have angle 1 and angle 2. We can conclude that those would have to be congruent. Now, if this is in a proof and you have some statements, you may have something like A is parallel to B. We can conclude that angle 1 is congruent to angle 2. Of course, when we're doing the converse of the alternate interior angles theorem, converse alternate interior angle theorem, we are actually doing the converse of that. So, if angle 1 is congruent to angle 2, then we can conclude that A is parallel to B. So angle 1 is congruent to angle 2, which is allowing us to conclude that the lines are parallel. All right, if we want to write that in symbols, angle 1 is congruent to angle 2. That allows us to conclude that A is parallel to B by the converse of the alternate interior angles theorem. So we did learn these rules in our first unit. It's just we didn't break them into theorems and their converses. We just used them to set up equations and find missing angles. All right, alternate exterior angles. If two parallel lines are cut by a transversal, then we can conclude that a set of, or any set of, alternate exterior angles is congruent. So I'll make those my alternate exterior angles. And of course, we can abbreviate that as converse alternate exterior angle theorem. Oh, wait a minute. This is just the alternate exterior angle theorem. This one is going to be the converse. I can abbreviate a little bit more. All right, so if I wanted to write that one in symbols, we would have A parallel to B implies angle 1 is congruent to angle 2. They're just in a different place as last time. And then the last one, the converse of the alternate exterior angles theorem. This time we're going to start with the alternate exterior angles being congruent and use that to conclude that the lines are parallel. Every converse theorem ends with concluding the lines are parallel. Oops. Angle 1 congruent to angle 2 implies the lines are parallel for the converse theorem. So those are the theorems associated with all of the rules that we learned in our first unit. So all of these theorems that we just went over, the corresponding and its converse, alternate exterior and its converse, alternate interior and its converse, can all be proven using the two postulates about same-side interior angles. Now let's talk about some little side theorems to do with perpendicular and parallel lines. The first one is called the perpendicular transversal theorem. Okay, it says if a line is perpendicular, so I'm marking all the given, the if part, to one of two parallel lines. So this line going up and down, which I'll call it T, is perpendicular to line A, which is one of two parallel lines. That's our given information, so I'll mark it over here as well. Then we can conclude it must be perpendicular to the other line as well. And we could do that using some corresponding angles. We could easily prove this. So if I wanted to write that in symbols, if T is perpendicular to A, and, here I'll use the and symbol, A is parallel to B, then we can conclude that T is also perpendicular to B, and we get that other right angle. We call this a corollary, a theorem that follows directly from another theorem. In other words, if you have the other theorem that it follows from proven, like corresponding angles, you could easily prove this rule here with just a couple extra, little couple add-on steps. Okay. Now let's look at the converse of the perpendicular transversal theorem. We're going to begin with two lines being perpendicular to the same line. So line T is perpendicular to line A and perpendicular to B. So A and B are two lines that are perpendicular to the same line, T. Then we can conclude that A is going to have to be parallel to B because, we've got corresponding angles that prove the line's parallel. So T perpendicular to A and T perpendicular to B implies A is parallel to B. This one isn't really a strict converse because one of the pieces of given information does stay in the, hypothesis. It doesn't completely all flip around, but it's close enough.
Antonio Stromolo, please.
We could reword, sorry about the interruption.
Stromolo to room 173. Thank you.
We could reword it where this T perpendicular to A is part of the hypothesis of the question, but we're not going to do that now. We're just going to leave it the way it is. So we have our perpendicular transversal theorem, which helps you show it's perpendicular to the other line. And then the converse theorem, as we said earlier, always ends with lines being parallel for these. Okay, the last rule, transitivity of parallel lines. Okay, that means if two lines are parallel to the same line, they are parallel to each other. We did this when we discussed equivalence relations. This is one of the things that we talked about. Parallelism is transitive. So I'm going to mark this as an if-then situation. So let's say I have lines A, B, and C. If you prove it, we would draw transversals and use angles, but I don't need that now. So I'm going to have line A is parallel to line B. Okay, and then I'm going to have line B is parallel to line C. So we can now conclude that a new set of lines is parallel that we could not mention before, which is going to be B is parallel to C. Oh no, we already got that. A is parallel to B, B is parallel to C, so A is parallel to C. I'm focused on my colors so much I messed that up. But I just wanted to mark them with different colors so you could see the red one is the new set of lines that is parallel. So A parallel to B and B parallel to C implies A is parallel to C. Perfect. My parallel sign doesn't look like. There we go. All right, so as I said earlier, the proofs of the corresponding alternate interior and alternate exterior angles theorems can be done using the same side interior angles postulate. The proofs of the converse ones can be done using the converse of the same side interior angles postulate. All right, so I believe we have 3 practice proofs that involve these things here that we will do in the next video. So I'm going to pause this here. Join us for the next video where we're actually practice some proofs involving these rules.